So, you pre-calc kids, last thing, then I can go home. What a funky looking problem, number 8. A box has dimensions 2 inches by 3 inches by 4 inches. See the illustration. Determine the angle theta formed by the diagonal of the 2 inch by 3 inch side and the diagonal of the 3 inch by 4 inch side. So this is what I'm interested in, okay? That's the angle I'm interested in. I hope you at least see that. There's theta, okay? You're going to have to do some Pythagorean theorem. You're going to have to get this side right here. This side is going to be 2 squared plus 3 squared equals c squared, which is what, 4 and 9. This is root 13. The other side, if this is 3 inches long, this is 3 inches long. All right. So this guy is going to be 4 squared plus 3 squared equals c squared, which should be a 5. My brain's working right. And your goal is to figure out what that angle is. That's your goal. Is there anything else we know? Oh, something they don't tell us that we need. We need that. In order to do this, I need that side right there. So what do I know about that particular rectangle? I know that that particular rectangle is a 2 by 4. That's what I know about it. And that would be the hypotenuse of a drawn-in triangle. So this guy is 2 squared plus 4 squared equals c squared, which I believe is root 20. And it's up to you whether you simplify or not. I'm actually not going to. The reason I'm not going to is because I know the formula that I'm about to use. You know, I like to say a lot of times, always simplify. 99 out of 100 times, simplification makes your job easier, but there's that 1 in 100 case where it doesn't. And this is that 1 in 100 case where simplification doesn't make your job easier. So I'm not going to reduce root 20 down to 2 root 5. I'm just not going to do it. The reason I'm not going to do it because I'm going to redraw this triangle on a clean piece of paper. So it's all not just jumbled up in there. And hopefully you'll recognize what law you're supposed to use. I'm going to use law of cosines. Now, since you have no idea, since you're interested in theta, you can go ahead and call it angle C if you want, if that makes it easier to use law of cosines, which it does. I'm going to use little c squared is a squared plus a b squared minus 2ab cosines of angle C. I'm just going to plug crap in and see where it takes me. This is going to be root 20 squared. It would be equal to a root 13 squared plus a 5 squared minus 2 root 13 times a 5 times the cosine of angle C. Assuming I ain't made any mistakes. And as quickly as I'd like to get out of here, as opposed to doing a chunk of this by hand, I know that, well, you may not realize, but anyways, we got root 20 to the second. We have to take away a root 13 to the second. We have to take away a 5 to the second. And that's the left-hand side. It's negative 18. The right-hand side, you can push buttons or whatever if you want. You don't have to. It's negative 10 root 13. You can approximate a decimal. It's up to you. Cosines of C. So now I got to do my division. I got a negative 18 divided by, if you're not approximating the decimal, make sure that you use parentheses or you use the fraction function. You can either do that or you can hit alpha x, bring up the fraction. Ideally, you actually don't even put the negative symbols in there. You just realize that negative over negative is a positive. Anyways, there you go, 0.4992. So, turns out that the cosine of C is roughly 0.4992. Then I arc it, and there's my angle. Little over 60 degrees. How do they want us to round? This is to the nearest degree. All right, so angle C is roughly 60 degrees. Very close to it. Well, wouldn't have guessed that that's a 30, 60, 90 pattern. It's darn close to it. All right, so that's 8. Here's the last one. Got a circle. Find the area of the shaded region of a circle of radius 25 centimeters formed by a central angle of 115 degrees. Round your answer to the nearest square centimeter. So here is a skill from Algebra 2 that I know you were taught because I know who taught you. You were taught in Algebra 2 that the area of a sector is 1/2 r squared theta. Theta must be a radian. That's the only thing about theta. It's got to be a radian. So I'm going to take my 115 degree angle and I'm going to convert it to a radian. 115 times pi over 180. If you want, you can use the decimal. It's up to you. 115 over 180. 23/36 of pi. 23/36 of pi. And when I talk about the area of a sector, I just forget that y'all are kids and you remember nothing. I'm talking about all of this, okay? All of this. The whole thing. But the area of this particular sector is going to be 1/2 the radius squared, which is 25, times 23 pi over 36. And again, you could have done a decimal over here. It wouldn't have been a problem because whatever I do, because we're talking about rounding the nearest square centimeter, I'm just going to round too. That's what I'm going to do. 0.5, 25, 23 pi over 6. Sorry, 36. And I got that the sector is roughly 25.09. What are the units here? Square centimeters. Now, I also need to know the area of this triangle, this little bitty triangle right here. And the area of that triangle is going to be 1/2 AB sines of angle C, the trapped angle. So 1/2 of a 25 and a 25 times the sin of 115 degrees. Make sure my calculator is in degree mode before I do anything, and it is. Cool. 0.5, 25, 25, sines 115. Triangle as a whole. Oh, Milbrath, you screwed up. Notice the formula is squared. I didn't put a square there, did I? I apologize. That was that line right there. I don't know how much attention you guys pay to me, but like you can hit second INS, rooftop, second. You don't have to retype everything. That's more realistic. Roughly 627.2. Hope you caught the mistake. Now, where was I? The only reason I actually noticed it is because the triangle's area was so much bigger than it was. So that line's right. 283.2. Now, you learned back in geometry that geometric, this isn't geometric probability. You just want the shaded region. And you did actually learn that skill in geometry. The shaded region is the area of the sector minus the area of the triangle, which that's the hint that's given down beneath, okay? So it's 627.2 minus 283.2. It's actually going to be a nice whole number based on the way I chose to round. 627.2 minus 283.2, 344 square centimeters. There you go, kids. I'll do my best to make you a test over the weekend. I just got to remember I got to do that. So, have a good weekend. Oh, fudge. I'm not even going to be here Monday. Ha! You're still going to have a test. I don't know how, but I'll get it up here.